As public agencies rapidly adopt sub-symbolic predictive algorithms, a critical tension emerges. How do we reconcile the mathematical reality of black box models with the constitutional mandates of due process and equal protection? The integration of automated biometric surveillance forces a collision between perceived administrative efficiency and foundational civil liberties. Welcome to Wandt courseware, an AI-narrated video series unpacking the latest lectures of Professor Adam Scott Wandt of the John Jay College of Criminal Justice in New York City. To evaluate how these technologies actually perform in the real world, we are going to synthesize the mechanics of machine learning, emerging global regulations, and existing civil rights doctrines. This dashboard organizes our analysis around three core texts: a foundational governance review outlining technical mechanics, the Global AI Policy Sourcebook 2025 mapping worldwide legislation, and a critical white paper from the Electronic Frontier Foundation on facial recognition. By examining these materials together, we clarify a specific burden placed on public administrators. A government agency cannot adopt a tool simply because it lowers costs or speeds up processing. Every deployment must guarantee compliance with the Constitution. The conflict between administration and technology starts at the structural level. For decades, traditional software relied on rule-based symbolic programming, clear, predictable logic trees where an engineer manually wrote the exact instructions for the computer to follow. This split-screen comparison illustrates the shift. On the left is that traditional, linear logic. On the right, we see modern machine learning. These are sub-symbolic predictive systems, functioning as a dense web of mathematical probabilities rather than strict, human-readable rules. As the nodes turn red, this mathematical structure introduces distinct administrative hurdles. One is data drift. As real-world conditions change over time, the statistical patterns the algorithm originally learned become outdated, causing its predictive accuracy to steadily degrade. Compounding the error rate is the black box explainability problem. Because the system calculates millions of sub-symbolic weights, the internal pathways are entirely obscured. The engineers who built the model often cannot explain the exact mathematical route it took to reach a specific output. These are not abstract coding errors. When an algorithm is deployed by a public agency, a miscalculation dictates who gets denied a housing loan, who is flagged for a tax audit, or who is incorrectly targeted for arrest. Traditional oversight mechanisms were designed to audit human logic and paper trails. When the decision-maker is an opaque mathematical model, those standard audits fail, allowing massive errors to operate completely unseen. Once technical flaws like data trust enter the physical world, they create complex civil liability challenges. Public sector managers are forced to answer for damages generated by systems they don't fully control, testing the limits of professional ethics. Currently, standard legal remedies offer little recourse. Traditional tort law struggles to assign negligence to an automated mathematical calculation, and Section 230 limitations frequently shield tech developers from the harms their algorithms produce. The most severe manifestation of this black box failure is algorithmic bias. When an opaque model is trained on historical data, it perfectly replicates the historical prejudices embedded within that data. MIT researcher Joy Buolamwini quantified this exact failure point. Her research tested facial recognition systems and proved severe intersectional accuracy disparities, demonstrating that the algorithms misidentified darker-skinned females at vastly higher rates than lighter-skinned males. When a public agency uses a tool with known intersectional failure rates in its hiring or policing practices, it immediately triggers specific legal violations. These statistical disparities directly violate Title VII and EEOC guidelines concerning disparate impact. Mathematical bias strips away long-standing civil rights protections. Because these algorithms systematically misidentify specific demographic groups, policymakers must construct entirely new frameworks to govern how this technology is deployed in the public square. To see how governments are attempting to manage these liabilities, public sector managers turn to the AI Policy Sourcebook 2025. It serves as a comparative index, benchmarking how different jurisdictions tackle algorithmic harm. Mapping this out on a horizontal spectrum, we see global governance strategies ranging from entirely voluntary guidelines on the left to strict bans on the right. On the far left of the spectrum is soft law. These are voluntary, principle-based frameworks that suggest ethical guidelines, but carry no legal penalties, such as the NIST AI Risk Management Framework and OECD principles. These soft law approaches prioritize international coordination and knowledge sharing, leveraging organizations like the OECD in Paris to build consensus across borders without stifling innovation. Moving toward the middle of the spectrum, we find risk-based legislation. This model categorizes AI tools by the specific threat they pose to citizens, applying heavier regulations to higher-risk deployments. The European Parliament set the primary benchmark for this middle ground with the EU AI Act, a massive legislative effort that creates binding compliance requirements for developers operating within its borders. This map illustrates the next critical step: translation. Broad international treaties and federal strategies ultimately rely on state and municipal governments, like Colorado with Senate Bill 26-189, to codify BINE into specific, enforceable administrative rules. New York City's Local Law 144 is a direct example of this local translation, mandating independent bias audits and transparency requirements for any algorithm used in employment decisions. The defining task for today's administrators is taking the high-level ethical commitments drafted in Brussels or Paris and designing the specific, auditable, local compliance protocols required to enforce them on the ground. But there are scenarios where mitigation and auditing are not enough. This brings us to the far right of the governance spectrum: command and control regulation. The Electronic Frontier Foundation outlines the strongest argument for this approach in their white paper, which advocates for a total, comprehensive ban on government use of facial recognition technology in public spaces. Looking at these statistical bar charts, the operational argument becomes clear. The EFF details that facial recognition systems inherently maintain significantly higher false positive rates for minoritized populations compared to baseline averages. The danger compounds when public agencies integrate these highly flawed identification systems into persistent mass surveillance networks, tracking citizens continuously without their consent or knowledge. The EFF argues that current legal frameworks simply cannot handle this capability. Existing Fourth Amendment protections, designed around physical searches, failed to restrict automated, persistent digital tracking in public domains. When sub-symbolic algorithms mathematically guarantee disparate impact and erode the rights of free expression and association, the technology cannot be safely managed. In these cases, the pursuit of public safety does not justify the adoption of the tool, and strict municipal bans become the only effective administrative policy. Synthesizing the technical mechanics of the black box, the global policy spectrum, and the EFF civil liberties argument brings us right back to the central tension: the friction between an algorithm's speed and the rule of law. As this balanced scale demonstrates, public sector AI deployments must face a rigorous test. Administrative efficiency metrics on one side cannot outweigh the constitutional mandates of due process and equal protection on the other. A mathematical model will always prioritize the optimization of data. True governance requires human administrators to apply continuous oversight, ensuring that public algorithms are tethered strictly to democratic accountability. Whether a municipality chooses to implement the risk-based auditing standards found in the global sourcebook or enacts a strict ban on biometric tracking, the foundational rule remains intact. Constitutional liberties are the priority, and the technology must adapt to the law, not the other way around. Like, follow, and subscribe for more deep dives into emerging technology, digital investigations, and ideas shaping our future. Remember, stay curious and want knowledge.